First of all, congratulations. You made it all the way to the end of the conference. And we are the last one standing between you and the happy hour. So we'll keep it short. My name is Kai. I'm with Uber. And every time when I tell my friends I work for Uber, the first question will be, oh, that's cool. So how many hours do you drive every week? And followed by the second question, do you also deliver food? The answer is yes. But in my spare time, I work as the lead product manager for the AI platform team here at Uber. And today with me on the stage is Raajay, yes, who is a senior staff engineer from the same team. And today we're going to talk about Michelangelo, Uber's internal end-to-end machine learning platform that powers 100% of Uber's machine learning use cases. I will start with explaining why we built Michelangelo and how the platform has been evolving in the past 8 years from the product offering perspective. Then we'll pass it on to Raajay to talk about the technical evolution of the platform. Before I jump into my presentation, let's do a show of hands. How many of you have used Uber in the past? Nice. How many of you have used Uber Eats? Some, okay. How many of you have used Uber grocery delivery? Okay, all right. Looks like our delivery team has a lot to do. With that, let's jump into the presentation. So today, Uber operates in 70 plus countries, over 10,000 cities, and with 150 million monthly active users, taking 28 million trips per day. And machine learning plays a vital role behind scenes and is incorporated into every single aspect of the product across all lines of business. Let's take the Uber Rides app as an example here. So when you log in, we use machine learning to authenticate your identification. And when you try to search for a destination, we use machine learning for autocomplete and also rank your search results. And once your destination is set, machine learning is heavily used for things like maps ETA, maps routing, pricing, and also product recommendations. And also, we use machine learning to match a rider and driver. And while you're on trip, we use machine learning for all kinds of safety measures. After trip is completed, machine learning is used for fraud detection for payments, and all the way to the GenAI-powered customer service bot experience. Same goes with our Uber Eats app, where we majorly focus on the recommendations, personalizations, and also the Eats ETD and pricing. And by the way, recently we rolled out a Eats AI assistant tool. We rolled that out to 1% of our US users, which is a chatbot in the Uber Eats app, which help answer questions about your dishes, restaurants, and also help you place orders through natural language processing. So if you open your Uber Eats app, you see that GenAI icon right by the search bar. You are lucky in that 1% of our early rollout. So give it a try, let us know how it works. All these use cases I just mentioned, they're all built and managed on this one platform called Michelangelo. But before we talk about what Michelangelo is about, let's revisit this concept of machine learning lifecycle. So machine learning lifecycle is a highly iterative process. You start from problem definition, then you collect your data, do feature engineering, prepare your training data set, then train your models, evaluate model performance, and you do this tens, hundreds, if not thousands of times until a good model is built. Then you deploy the model into production. Another iteration starts because now you need to periodically retrain your model because your model performance will degrade. It's just a matter of time. And sometimes you just want to further improve your model performance. Then you go back to the development, try different model architectures, different features, and repeat the whole process again and again and again. And this whole process is highly collaborative. It requires different user personas to collaborate closely to launch a machine learning application successfully into production. Actually, the process looks more messy. It looks like this. So prior to Michelangelo, each of the machine learning teams at Uber, they built their own ad hoc pipelines and workflows to meet their machine learning needs. These one-off pipelines were difficult to manage, non-reusable, hard to productionize, and impossible to scale. which led to inconsistency in model performance, and also just duplicate the effort across teams. And also, the teams at that time, they focused on the offline evaluation and offline model performance during the training time. Once the model is deployed, they actually don't track that much about the model performance in production. So that leads to production machine learning quality degradation. This is where Michelangelo comes into the picture. Michelangelo provides this one centralized machine learning platform for our machine learning developers to manage the whole machine learning lifecycle end-to-end without worrying about the underlying infra and system complexities. We ensure machine learning quality by embedding the best machine learning practices learned through our years of experience supporting all the Uber machine learning use cases directly into the platform. For example, when we deploy a model, during the deployment, we incrementally roll out the model zone by zone, region by region, instead of deploying the model to all the zones at once. And if any issue is detected during the model rollout, we automatically roll back the model to prevent outages. Also, once the model is deployed, the performance monitoring and data monitoring are automatically set up, and the alerts will be sent to our users if anything is detected. And we also automatically retrain your model if your model performance degrades. And our strategy of building Michelangelo involves actively evaluating and integrating industry-leading third-party components and selectively investing in in-house areas to build in-house. This guarantees that we can always provide the best-in-class capabilities to machine learning developers at Uber, be it from open source or third-party vendors or built in-house. And because everything is managed and built on this one centralized platform, it's very easy to track and audit the machine learning usage across Uber. And that also enables us to meet the responsible AI principles and requirements. And lastly, this centralized platform and the team actually enables the leading of this company-wide machine learning initiatives. For example, back in 2021, the AI platform team led the adoption of deep learning at Uber, which drives the deep learning adoption rate to 60% today at Uber. And today, we are driving the Gen AI innovation and adoption. So the evolution of Michelangelo can be roughly divided into 3 different phases. So Uber started its Gen AI machine learning journey back in 2015 when the few teams like risk, maps, and pricing, they started exploring the possibility of replacing rule-based engines with machine learning systems. That's when we started Michelangelo to actually enable these teams and a few other teams so that they can actually leverage machine learning to drive business impact. So at that moment, the goal was all about enablement of machine learning. The first tool we launched was a Michelangelo UI, which is a simple UI tool for classic machine learning models development and deployment. In the next few years, we launched the Machine Learning Explorer, which is an workflow automation and orchestration tool to automate some of the processes during the machine learning lifecycle management. We also launched our feature store called Palette, which allows users to compute features, store, discover, and also reuse the features across the company. And to our best knowledge, this was the first time the concept of feature store was introduced to the machine learning community. We also built the Model Excellence School, which is a framework for machine learning model and data quality monitoring in production. So by the end of 2019, most of the product teams, they had already adopted machine learning. So our goal was not to enable machine learning anymore. So that's why starting 2020, we pivoted our goal from enabling machine learning everywhere across Uber to focusing on the key projects with high business impact to see how we can actually improve the model performance for these projects by driving the deep learning adoption and also model iteration as code. Moreover, we also consolidated all the existing UI tools which were built by different sub-teams with different UX UI designs, as you can tell from the previous slides, into one unified UI. And also, we completely redesigned the UX and user flow to deliver a more seamless user experience to our machine learning developers at Uber. Then 2023 marks another start of the major innovation of the platform to by extending the Michelangelo to build the Michelangelo Gen AI ecosystem to support the generative AI application development at Uber. At its core is this Gen AI Studio, which allows our users, which provides a central hub that allows our users to build all the different Gen AI components, such as prompts, your RAG applications, and also fine-tune your model if needed, and also evaluate the model performance. And it also comes with this Gen AI gateway, which provides a unified interface for our users to access either the external models such as GPT-4 from OpenAI or Gemini from Google, and also the open source models served from Michelangelo, such as Mixtral and Llama 2. It also comes with the security and the safety capabilities, such as PI reduction and safety guardrails. And to support the generative AI application development, we launched the Gen AI app framework, which is actually based on the open source LangChain. It allows users to chain all the components you build in Gen AI Studio, plus the access to the Uber internal data and the tooling. And this drastically improved the velocity of how our developers to build and launch Gen AI applications. And we have another cohort of users. These are the non-coders. They're not developers. They don't write code, but they still want to leverage generative AI. So for those users, we actually launched a self-served, no-code UI tool for users to build Gen AI assistants or co-pilots. And again, with the Uber internal connectivity and the knowledge. So with the launch of Gen AI Studio and the Gen AI ecosystem, now Michelangelo supports both the classic ML ops and also the LLM ops. So looking back at our journey, we started back in 2016, building the Michelangelo 1.0 to support classic model, linear tree model development and deployment. Then we move on to deep learning with Michelangelo 2.0, and now we majorly focus on generative AI use cases. And today, 100% of Uber's most business critical machine learning projects are built and managed on Michelangelo. Every month, there are 20,000 models trained. At any certain moment, there are more than 5,000 models serving production traffic in real time and making 60 million peak prediction per second. With that, I will pass it on to Raajay, who's going to talk about our technical evolution of this platform.
Thanks, Kai. Hello, everyone. We heard from Kai about how the ML landscape and all the product has shifted over the time. I'll briefly walk you through our technical stack design, basically to highlight how a single stack can adapt to these tectonic shifts. So what do I mean by that? So 2016 to 2019, we were predominantly tree-based models running on Spark, but today we support LLM inference and LLM training on the state-of-the-art hardware. To understand this journey, let's start from the beginning, right? So like I mentioned, and I want to talk about our tech stack along 3 dimensions. There's a data plane, which talks about the training and the serving. There's a control plane, which lets you do model management, prompt management, tracing, debuggability, and whatnot. And then there is this third pillar, which is the ML developer experience, which is the set of features that we build that helps ML model developers, Gen AI app developers to actually iterate very fast. So 2018, we were mainly XGBoost, tree-based, running on Spark for training, and we had our own internal Java-based serving engine. The problem then was basically scaling XGBoost training to over 1 billion rows. And as the data set grew bigger, the models became bigger, and we also had to start solving the problem of how do you serve these large models with very low latency. The control plane was very rudimentary. We had a REST API that will let you submit jobs, list them, kill them, and whatnot. And then we had a model management API that will let you deploy the model. We had different environments to deploy the model, retire, and whatnot. The ML, and we also had a separate API for orchestration, which is basically the retraining. I think the key takeaway here is that it was a bunch of ad hoc services that were put together to serve ML ops at Uber. The ML dev experience was also very, very simple. All the model authoring was UI based. So as a model developer, you go to the UI, you say, hey, I need an XGBoost model with so many trees, with so much depth, and this is the learning rate, and that's how you iterate on it, right? And with respect to the feature engineering part, where you want to do some transformations or fill in default values and whatnot, we had our own Scala-based DSL that will let you iterate. So if you wanted to remove a feature, you basically commented out a line here, and if you wanted to add a new feature, you add a new line and write it in Scala what you actually want the transformation to be. Not only did we have that, we also had a separate stack for managing all the deep learning applications. At this point of time, ATG was part of Uber, and we had a deep learning stack to train all these models that helped with autonomous driving. And we wrote Horoward that allowed distributed data parallelism. It was predominantly TensorFlow models at the time. It has its own control plane, and the user experience was completely different than what the prime use cases we're using, because in this case, people just write raw free-form Python code using native, all-reduce APIs or TensorFlow APIs. This was a problem for two reasons. One is our prime use cases now we're starting to explore. When I say prime, it's the core rider and the core eater use cases. They also wanted to start deep learning solutions to improve the model accuracy. Right? And we were also maintaining two stacks here, and that was also inconvenient. So we thought about it, and that initiative, we started the Michelangelo 2.0 effort, where we wanted to rethink what it means to create a stack that can quickly adapt to these big changes that we see in the ML industry. So we started with what we had, and then we added Ray into the ecosystem. We added Ray primarily because to support all the advanced training, Spark has this communication model where everybody executor talks to the driver, but Ray has a much more all-to-all communication pattern. So we brought in Ray here, and we moved all of our training on top of Ray. We also brought in PyTorch as a first-class citizen because PyTorch was gaining a lot of traction in the developer community, and all the new models were actually written in PyTorch. On top of it, we also GPU-fied our stack, if that's a word. Basically, we started supporting GPU for training as well as serving. We rewrote our control plane completely based on a Kubernetes pattern. We got rid of all our APIs, and the model that we went with was we'll have CRDs to represent the key components in machine learning, and we'll have controllers to act it. And this controller pattern is extremely scalable, and we'll talk about this when we talk about the GenAI stack and how it helped in adapting very quickly. We also rethought the ML dev experience because with deep learning, it was no longer just you clicking a few buttons and selecting a few parameters. Users wanted to bring in code. But they also wanted to bring in config when config made sense. So we came up with an application framework where we were super opinionated about how models will be trained in Michelangelo. So if you want to train a model, you need to stick to this template where you have these 4 steps. You do your feature prep, your transform, your train, your assembler, which takes care of model quantization and packaging and whatnot, and then the evaluator in itself. The platform will provide you a basic template, which you can use directly by configuration, or which you can extend it. We had templates for model training and model scoring, and which users could now config. And also in some of these configs that if you note, these have pointers to Python functions where you can actually bring in your code. Let me spend one more slide to highlighting what the dev experience would be in this framework. So we start with what does the user do if they want to define a pipeline, right? They actually check out a repository and go edit one config file, and then they write whatever code they want to define their model architecture. Then, and you will notice that once they have written the code, they push it to our platform, so it is all revision controlled, which helps in reproducibility. Once they have a revision, they actually run the revision then, and then you have very nice visibility into all the steps, their statuses, what are the inputs and the outputs that each of the step generates. And then let's say you look at this model that was created, hey, something doesn't look good, I want to debug what is happening. You can go and click a button that will give you a notebook as an option, and this will have all the values preloaded from your prior execution, which we can go explore and deep dive into. And let's say you found the issue and you fix it, then you you create a new version of the pipeline, and then you resume from. The key thing to note here is that when you resume from, let's say you made a change in the trainer, you don't have to run the previous steps. And this is only made possible because we have a very strict lineage and checkpointing of all the intermediate data. Finally, when you're happy with your pipeline, you land it and productionize it and get it ready for deployment. So we had this stack, great, and I talked about it, but where is the quality part and where's the Gen AI part? I think the point that I want to highlight next is that having this pluggable data plane and control plane helped us migrate very, very quickly to the shift in all the ML use cases at Uber. When the number of Gen AI use cases actually increased, we had to respond very fast. There were users that will ask like, hey, we want to do fine tuning of the model. There were users that would want, like, we want to evaluate this model, OpenAI, on a very large data set, right? So as a platform, we had to provide solution. But the fact that we had a very pluggable, both pluggable control plane and the data plane, we were able to do it. So we added deep speed and Hugging Face as trainers that will let you fine tune Llama or any of the open source models with Uber specific data. We also added TensorRTs to the serving stack to help with multi-node model parallel serving. The control plane changes were actually super minimal to support Gen AI use cases. We now had to just add new CRDs and controllers for concepts that were only applicable to Gen AI stack and not applicable to the ML stack, like prompts and external models, evaluation data sets, so on and so forth. From a developer perspective, what we ended up doing was we created new templates. We had templates for your predictive AI, your classification, regression, and ranking problems. Now we created new templates for LLM training and scoring, right? And this will let you do things like fine-tuning an open source model. This will let you, but one of the most common application actually here is the evaluation application, where users will bring their data set and say, I want to evaluate which of these models are really good. So we have templates that will let you just specify, I want OpenAI model to be evaluated, I want Gemini to be evaluated, and this is my data set. Our framework will go run it and give you actually scores. Because we have a framework approach to things, we are easily able to scale out the metrics that we compute and make sure the metrics that we think are good are applicable for every single Gen AI app that is running within Uber. One additional tech that we had to build was the Gen AI application framework. This is a Python-based microservice framework. It's based on LangChain that will let users write Gen AI applications very quickly, like chat applications, code completion applications. You can build all of these very quickly. The platform team mainly works in the bottom part of things, where we are responsible for logging, we are responsible for tools, and we are responsible for all data connectivity within Uber. Well, the users can just go write the main functional part of the app themselves. The way this works is, once you onboard to the Gen AI application framework, logging, everything comes to you for free, and this logging can feed into your scoring applications, which has your evaluation as well, and it will continuously generate metrics for you. Because we are opinionated, there are a lot of metrics for these chat applications that come free. So the key message that I want to give here is that having this pluggable framework helps us respond really quickly to these tectonic shifts, and also having them pluggable, also being opinionated and pluggable has two advantages. Being opinionated helps us scale the good metrics to everybody at Uber, and it being pluggable lets some of the users go ahead of the pack, implementing whatever they really want to build. With that, I'll hand it over to Kai to summarize all the learnings we had over the last 4 or 5 years, or maybe more than that.
All right, thanks, Raajay. We've learned a lot along the way, along the past 8 years. I want to share some of our lessons with you folks. So first of all, having this centralized platform and also having this centralized platform team really benefit the companies where you have multiple product teams want to leverage machine learning to drive the business impact. It helps drive the standardization and consistency. It reduces the duplicate efforts. It also enables collaborations, which in turn actually can improve your machine learning quality and also improve your dev product activities. Secondly, let the developer choose what tools they want to use. We provide a UI tool for the users who doesn't want to write code to build like tree-based models. We also provide a code-driven approach for users to write highly complex model implementations, and also provide a high-level abstraction with pre-built templates for most of the users, but still allow your advanced users to directly access your low-level infra and compute resources to build highly customizable workflows and pipelines. And I mentioned this already, design the platform in a modularized way so that each component can be built in a plug-and-play way. This really enables the rapid adoption of the best-in-class machine learning capabilities for your company. And ML as code is preferred, it's very useful, but it's really hard to do. But we proved that it's doable. So we want to let you know. It helps improve the machine learning quality, reproducibility, and also enable collaborations. And deep learning is expensive. Do not use deep learning everywhere. Only use deep learning when the ROI actually makes sense. There's a reason we only have 60% of models in production are deep learning, not 100%. There's a very good reason for that. And lastly, not all the machine learning projects are created equal. When we started, there were only 3 projects. Yes, we can, we're able to pay the same attention, give the same resource to all these 3 projects. Today, we have more than 700 projects. There's no way we can just take care of all the projects in the same way. Focus on your most business critical projects here. For example, at Uber, those projects are our ETA model, our ETD model, home feed ranking model, risk model, fraud model, and others. I think that's what I have for today. I hope you enjoyed the talk and enjoyed the happy hour. Thank you.
Would you like any Q&A? We have time for two
sure.
quick questions.
Yeah, sure.
People are ready for a happy hour, but we got a couple quick questions right here.
Hey, thanks. Could you share what percentage uses like the generative AI applications at Uber?
The real ones in production is very, very small, the percentage. I can't specifically tell the number, but it's very, very small. I can tell you still more than 95 or even 99% of our business are rely on the predictive machine learning still. Yeah.
All right.
All right, thanks for that talk. Yeah, can you talk a little bit more about the use cases that internal developers have been using the Gen AI platform for?
Okay, let me see what I can say. For example, some sample use cases, as I mentioned, right? We built this Ease AI assistant. We roll that out to 1% of the US users. So that's one of our Gen AI use cases. And now, if you go to the customer service, the first line of responders, those are actually LLM-powered chatbots. And we are also, no, I cannot say that. Sorry, that's it. 2 of them.
All right, one more question. Good. All right, let's give it up for them one more time.
Thank you.